Hello, everybody. Thank you for attending. Happy Friday. And welcome to what is part 11 of our 13-part series of What's New in SQL Server 2012. We probably have some people attending for the first time and some people who might have been attending for several weeks or maybe even going back to the very beginning. But we've been covering the new features in SQL Server 2012. And this particular week, we're going to look at DAX programming, which is the programming language that we can use with PowerPivot and with the tabular model. And we've been looking at the tabular model and at PowerPivot the last couple of weeks, and I've actually pulled up some DAX samples the last few weeks already. Well, I'm going to pull them up and talk about them more in detail and also show some new DAX code as well. So we'll get to the examples here in just a moment. My name is Kevin Goff. I'm a SQL Server MVP, and I work and train for a company called SetFocus. They're located in Parsippany, New Jersey. I'm a trainer and a practice manager in the SQL Server and Business Intelligence area. And just a very quick background about me. First of all, again, this is a 13-part series that I've been working with Microsoft on going back to the early part of this year and coming up with a series that just has a just the facts approach, very example and demo based approach to looking at the new features in SQL Server 2012. And just a quick bio on me. As I said, I'm a Microsoft SQL Server MVP. I write for Code Magazine, mainly on database topics. Written a couple of books. I do speaking primarily in the Mid-Atlantic area, different SQL Saturday and SharePoint Saturday and Code Camp events. And as I said, I train for a company called SetFocus. Just a very quick blurb about them. We actually have a free training portal. We have about 100 hours of free training lifted from our actual curriculum. You can go to http://freetraining.setfocus.com, and you can actually get over 100 hours of free training. It's actually been lifted from our curriculum in .NET, SQL Server, Business Intelligence, and SharePoint. And you go to our main company site, which is setfocus.com. As far as I'm concerned, my email address is kgoff@kevinsgoff.net. So if you have any questions afterwards, feel free to send me an email. Also been covering this webcast series on my blog. My blog is www.kevinsgoff.net. You can actually go over to the Microsoft webcast area. I have a separate category on my blog devoted to this webcast series. So you can go there for coverage and for downloads of prior weeks as well as registration links for any upcoming weeks. Well, we are again on week 11. Time flies. Seems like just yesterday we were looking at the new column store index and new T-SQL features. Well, now we're up to week 11 and looking at the new DAX features. Actually, going to talk about some new features and some older features, since even DAX 1.0 might not necessarily be considered all that old. And so we're going to look at how we can use DAX in different business application scenarios. Now, next week, we're going to look at the new reporting services integration capabilities with SharePoint 2010. And then in the final week, 2 weeks from now, we're going to take a look at the new data visualization tool that's offered in SQL Server 2012 inside of SharePoint, and that's called PowerView. So weeks 12 and 13 are almost a part 1 and a part 2 on the new reporting capabilities. Next week we'll focus on the existing reporting services integration with SharePoint, and then the following week we'll look at the new data visualization tool called PowerView. So let's get into the actual examples for this week. Now, as I said, we've looked at some DAX code the last few weeks as I was going through some examples in PowerPivot. Kind of hard to show examples in PowerPivot without showing at least a few basic DAX functions. Well, we're going to go back and review some of them today, but we're also going to look at some new capabilities. Going to look at overall DAX expressions. Going to look at how we can put DAX queries into Management Studio and run them. I showed last week, and I'll show again this week, how we can put DAX formulas into a tabular model inside of SQL Server data tools, or even into PowerPivot in Excel. Well, we can also test out DAX queries in Management Studio, so I'll show how we can do that. I'm going to show a really nice DAX function called rollup that, as the name implies, can allow us to roll up data to a particular level. Going to look at calculating averages, both straight averages as well as moving averages. Going to look at how we can provide some chronological aspect to our result sets by using things like quarter to date and year to date, and also doing things like getting sales for the same time period a year ago. Whether you're looking at a month or looking at a quarter, you may want to see what were your sales 1 year ago at that time, or based upon month or quarter. So we'll see how we can do that. Going to look at the rank function. Actually looked at that a little bit week before last. Going to look at that again today. Rank is something that for some people is extremely important to be able to show the rank position of a set of salesmen ordered by sales dollars, or a set of products ordered by sales dollars, and rank them 1 through 5 or whatever. Well, rank actually is a new feature in DAX 2.0. It wasn't in the original version of DAX, and if you have ever tried to write a rank function manually, you know how difficult it can be. Well, fortunately, they have a rank function in 2.0 now, so we don't have to write our own logic. We can take advantage of the new function. Now, the next 2 bullet points are kind of interesting because I've talked a few times about areas of the full-blown version of analysis services when we build multi-dimensional OLAP databases, and how sometimes when we use the tabular model or use PowerPivot, we do lose some functionality, at least some built-in functionality that's in the full-blown version of analysis services. Well, 2 such examples are implementing what are called Roleplaying Dimensions and calculations involving many-to-many bridge tables. Those are things that where there's built-in functionality in the full-blown version of analysis services that don't quite exist in the tabular model, at least not the way that we would like. Well, the good news is that we can address some of those shortcomings with some custom DAX code. So we're going to look at an example of Roleplaying Dimensions, a very, very common example where we want to look at revenue associated with a shipment time period, or with an order date time period, or with a due date or a delivery date time period. We call that a role-playing dimension because the date can serve multiple roles, multiple purposes. Well, in the full-blown version of analysis services, it's actually pretty easy to do. With a tabular model or with PowerPivot, we have to write a little bit of DAX code, but it certainly is doable. And then we're going to look at a DAX calculation involving a bridge table. We actually saw this a few weeks ago where we had sales dollars by author. And an author might have written a portion of a book. Well, trying to take the sales dollars and apply the author's share can be a little bit involved. We actually have to write some DAX code to do that. And then finally, we're going to look at a function that if you're an MDX developer, if you've written MDX queries against OLAP databases, you might have had to use the generate function. Generate is one of the more powerful functions in MDX. To allow you to do things like get the top 3 products within the top 4 sales regions, basically a top count within a top count. Well, in MDX, you use the generate function to accomplish that. Well, generate also exists in DAX, so we'll take a look at how we can do that. Well, going to hop over to my desktop, so I'm going to get out of the slide deck and go to my desktop. And give this a second to load. Now, what I've done ahead of time, because the topics that I've talked about actually cover a wide range of examples, unlike when we built the AdventureWorks tabular database, or when we built that book sales database using PowerPivot, I was able to go through a logical set of sequences. This is more or less a miscellaneous set of DAX examples. Now, it's impossible to train DAX in an hour. As a matter of fact, some people who work with DAX feel that even though it might be billed as initially very simple, and for simple calculations that's definitely the case, For more involved calculations, it can be just as tricky as MDX code. So the tact I'm taking here, as opposed to maybe training on maybe just a few examples, really trying to cover a more wide range of different DAX features, and give you some resources at the end that you can utilize if you want to go research DAX a little bit further. Well, first of all, some very, very basic DAX formulas we don't even need to write, because the tabular model or Excel with PowerPivot can do it for us. As an example, if I go back to Visual Studio, we're able, as we saw in a couple of demos we've done already, we're able to point to any column that we set up in a tabular model for which we want to do an aggregation. Well, we can actually click on that column, like the product standard cost, and we can click the drop down for the aggregation capability, and the default aggregation here is a sum, but we got some other ones as well. If we want that to be a measure that the people can see when they utilize this model, so we can sum the product standard cost, and that generates a very, very simple DAX expression, about as simple as you could possibly have, that simply sums that measure. Can't get any simpler than that. And for that, we don't even have to write it, because we can just simply take the option after clicking on the measure, taking the option in the toolbar to aggregate that. So for that one, we don't even need to write anything. We can use the built-in tools. But then eventually they get a little bit more complicated. We looked at things like a returns percent. That was actually back when we did the book sales database example. We looked at an example of a returns percent. Well, with that one, we wanted to take basically the sum of the return dollars from the factbook returns fact table and divide it by the sum of the sales dollars from factbook sales. Now, where that wound up going, and I may have to pull up the tabular model for this. Bear with me just 1 second. Where that wound up going, the calculation for the returns percent, because it's really associated with factbook returns, we put it into that fact table. You generally want to put any DAX calculations in the fact table that's really from a business standpoint, or just from an application standpoint, is associated with that fact table. Well, that returns percent itself was actually used to create a KPI. We implemented a KPI involving that returns percent. And again, the calculations, coming back to Word here, and by the way, I'm going to put this Word document up on my site so that everybody can have access to it, was again the sum of the return dollars from factbook returns divided by the sum of the sales dollars from factbook sales. Now, we wanted to round that to a particular number of decimal positions. I rounded it to 4. And because factbook returns was actually had the return dollars stored as a negative, and maybe I want to render that returns percent as a positive, well, we can use a basic absolute value function to wrap around that. So this one is, certainly not much different than you would see with any other database language. We reference the fact table and then the measure in parentheses, and we're taking the sum of the return dollars divided by the sum of the sales dollars. So that one is pretty easy to get. Now, we also, in this example, had a return goal. We had a return goal that came from our thresholds table, because the goal itself wasn't a hardwired number. It actually came from a fact table. So we had instances where for 1 year and for one customer category, the return goal might have been 14.5%, and then maybe for another year, say for 2007 here, the goals might have been a little bit different. Well, in that case, I could actually even right-click here in in the PowerPivot field list and edit the formula and see what was in it. It's basically the same as what I have in the Word document here in the background. Well, I'll use what's in the Word document since it's a little bit easier to read. Well, in this case, we wanted to average the return threshold because someone might look at sales and returns for a year across all customer categories. So we might have 5 different return thresholds that we want to do a straight average on. Well, in this case, what we can do is we can average the return threshold from fact return threshold. And then what we want to do, because as I come back here to Excel, we might want to look at that over a scope of year from the date dimension and customer category from the customer dimension. We use a function here called Calculate. Calculate is essentially going to, as the name implies, run that average over a scope of data. In this case, from the related table in dim customers and the related table for dim dates. So anytime that we want to run some type of a calculation, whether it's a sum or in this case an average, and run it over a set of related dimensions, well, we can put the average function inside of the calculate function and then run it over a set of data using, again, the DAX function called related table. And in this case, I've got 2 related tables. Again, the customer dimension and the date dimension. Since I'm looking at this return threshold by its dimensionality, by its granularity, if you will, the year and the customer category. So that's where DAX formulas get a little bit more involved. Now, fortunately, very easy to test these out because we can simply put a new formula here in Excel in the PowerPivot field list. If I wanted to put a new calculation in, I can just right-click and add a new measure, and the Excel interface here basically gives me the ability to put in a new DAX formula and put in a name and test it out here in the interface. Well, other ones that we had in here, we had a returns rank where we displayed each of the, in this case, the books ranked from high to low based upon the returns percent. So in this case, quantum books for 2007 and for the customer category of distribution centers was ranked number 1. Well, in this case, 1 is not a good thing because that's the highest return percent and obviously not a good thing. Well, as I said a little while ago, there actually wasn't a rank function inside of DAX 1.0. And if you've ever had to write a rank function, you know it's not the easiest thing in the world to write. If you think about it manually, when you implement a rank, you're essentially assigning a position where you might even internally do a count of the number of rows where the returns percent is either greater than or less than the current row. And you have to do things like not taking into account the current row when you do that check, and also not displaying the rank value when you in this case when we aggregate all of the books up to a grand total. Well, as I said, DAX 1.0 didn't have a rank function at all, but fortunately 2.0 does. Well, there's a function called rankx. Now, I've embedded it inside a couple of other things here. I'll talk about the 2 if statements up above in a minute. Well, essentially, we want to rank the returns percent from fact book returns across, in this case, and then I said these are books a minute ago, these are actually customers. These are customers associated with a customer category. So if I change this to retail store, I get all the retail stores. And again, this is just made up data. I realize I have some actual names in here, but this is all fictional data. These are not actual sales amounts. So as I click a different customer category, the PowerPivot model under the hood is automatically slicing the dollars by in this case the related customers for each customer category. So the rank function itself is allowing us to rank each of the customers using customer name according to the returns percent. And by default, it's going to do it from high to low. So rank X is going to return basically a position of each value with respect to the set, with respect to all of the customers who happen to be in the current scope, where all the customers are in the current scope could be 10 customers or 2 customers. Now notice the additional if checks, because we, first of all, only want to rank if we actually have customers. So notice we do account rows, we're excluding the total. And we also want to rank if the current customer is not a blank. That second check here, the checks if the current customer name is not blank, is what's going to keep a rank from showing here. We don't want to rank the grand total. And so to avoid that, we can have an if check. And this is code that you'll see in a lot of different books, a lot of different websites, weblogs that talk about the rank function, that you might put an if check up above to make sure that the current, in this case, the current customer is not blank, which is what it is for the grand total. So that's how we can implement a rank in DAX 2.0. Certainly much easier than what we had in DAX 1.0. All right, so we've looked at the first couple of here. We looked at the return dollars, the return percent, the returns rank, the returns goal. Well, we also the other week looked at a more involved calculation for author dollars. Now, if I come back here to the example, I had a list of fictional authors down the left here, and I had 2 columns for author dollars and for royalty dollars. Now, the reason for these calculations is this: in the sales table, we have sales associated with basically with a book, not with an author. And a book can be written by many authors, and an author can write multiple books. Well, if an author is involved in a book where other authors also wrote it, for instance, author 5 here might have written one book where he or she contributed 25% of it. So the author dollars needs to take the sales dollars for the book and then factor in the author share. Well, if you remember the actual data table relationship we had for that, it was let me see if I can go back to the PowerPivot window and take a look at the underlying data for this. So I'll go back and look at the data model. I'll go back to the PowerPivot model, look at the data model here to help explain why we need this calculation. So I'm coming back to the data model. And look at the diagram view. And give this just a second to load. And again, we had a fact table, fact book sales, with the sum of sales dollars. Now, there's no relationship to author, at least not a direct relationship in here, because we don't sell an author, we sell a book that's related to the author in some way. Well, we had 2 dimension tables called dim book price and dim book for each book, and then the historical instances of the book's price. Then we have this author dimension all the way out here with a list of authors. Well, the authors are related to the book through the bridge table, because again, one book might have multiple authors on it, and an author might be involved in multiple books, where the author's share of the book might be different every time. So this author share for any one book could be 10, 20%, 50%, however much the author wrote. Well, if a book sells $1 million, we don't want to show if we look at sales by author, we don't want to show $1 million because we'd be double counting data if that author was one of multiple authors in the book. So essentially, we want to take the sales dollars and apply the author share to it on an author by author basis. Well, The full-blown version of analysis services supports a calculation like that actually fairly easily because it has direct support for many-to-many relationships. With PowerPivot and with the tabular model, not quite as simple. In order for us to be able to associate the sales with the author, we had to come up with a calculation called author dollars. Now, essentially, in this case, what we wanted to do, there's a DAX calculation called SumX, and what we want to do, because the authors are associated with dim book price through the list of books, internally, what we want to do is calculate the sum of the sales dollars and multiply it by the author share from books to authors. But we have to do this from the relationship and from dim book price. So sometimes people, when they try to write a calculation involving a many-to-many relationship, they wonder, where do we start? Do we drive this from fact book sales? Do we drive it from authors? Well, we actually drive it more or less from the middle, from dim book price, because dim book price has a relationship to fact book sales, and it has a reference relationship to book to authors, where we have the bridge table through dim books. So we wind up doing a SumX from the dim book price dimension, and then once we have a relationship into there, we can sum the sales dollars and multiply it by the author share. And then if we want to go one step further, if we want to calculate royalty dollars, now I could have actually taken the author dollars and applied the author royalty. I've repeated the author dollar calculation here just to be expressive, and then we can turn around and multiply it by the average royalty, because we could be rolling up multiple records, so we want to get the average author royalty that was also in the bridge table. So if you ever find a need, and not everybody has to do this, but if you ever have a scenario, if you ever have a pattern, and software development and database development is all about patterns. If you ever have a scenario where you have a fact table and a dimension that is seemingly out of reach, where it's only accessible through a bridge table relationship, and you want to apply an aggregation in the original fact table to some type of ratio or percentage in the bridge table, this is the pattern that you can use. So you could apply this to several different scenarios and get the same result. So this is a situation where a DAX formula can help us when the built-in relationship model in PowerPivot or in the tabular model doesn't quite do what the full-blown version of analysis services does. A little bit later, I'm going to talk about another scenario where we have role-playing dimensions, where we can calculate shipment dollars and order dollars and due date dollars. We'll look at that in just a little while. So we've looked at these first couple here. The percent of total, I'm going to actually skip that temporarily and come back to it. I want to, because I'm in this book sales demo, and I'll close the PowerPivot window and go back to the Excel spreadsheet. I want to focus on the DAX formulas I used here, and then go over to AdventureWorks or some of the other DAX formulas. Well, another thing that we did was we calculated a moving average. That was one where we constructed a chart where we displayed on a 12-month basis for any calendar year the aggregated sales for that month, and then the moving average, which is basically for any one month the average sales over the last 12 months. And since we're moving forward 1 month every time, we get a new 12-month range. That's why we call it a moving average. So the key to this is calculating for any 1 month, like in April of 2007, what the range of the last 12 months happened to be. And this is never a simple calculation. People who have written moving averages in T-SQL or in MDX or in other languages know that it's not something basic, and in DAX certainly very similar. Well, I actually broke this out into four different calculations. We could We could have done it as 1 or 2, but I broke it up into 4 to be expressive. Well, the first thing we need to do, if we're trying to determine the 12-month average, is for any one month, get what the last 12 months happen to be. Now, in this scenario, we want to exclude the current month. So in September of 07, to get the 12-month moving average, we are essentially hopping back 1 month and then going back 12 months inclusive. So the 12-month range in September of 07 would be August of 07 going back to September of 06. Well, to determine that, there are 2 functions in DAX called start of month and end of month. Because we want to, again, if we're using September 07 as an example, we want to go back essentially to September the 1st of 2006 and average the sales up to August the 31st of 2007. So we're looking to determine that. But again, we have to determine that in an abstract fashion because the current month is going to change every time. Well, to get the start month, we could use the function in DAX called start month. Well, what we can do is we can take the concept of the current date, which we can derive by referencing the date dimension and the actual date, and add a negative number of months by using the date add function to add negative 12 months. So again, if we're on September of 2007, well, we can basically subtract. There is no date subfunction, so we call date add and we pass in a negative. That basically gives us September of 06. And we want the start of that month, which will actually give us September the 1st of 06. Well, then the end of month is same concept. Once again, if we're doing this from the base point of September 2007, we want to hop back 1 month, in which case we give us August of 07, and then grab the last day of that month, because we're looking to get August the 31st. So we need to have 2 DAX formulas internally that'll determine what the starting month and what the ending month happen to be. Well, once we have that, everything else is fairly straightforward. We need a calculation that determines the concept of an average over a set of months. And so we'll have a calculation called average sales that will take the sum of the sales dollars from fact book sales and divide it by the number of distinct months that are encountered. Now, this count rows is actually important. You would think it would be a value of 12, but keep in mind something. We might be going back 11 months or 10 months. Maybe we only have 10 months worth of data. So in that case, we only want to go back to the number of months for which we actually have data. So instead of this being a hardwired 12, we wound up counting the number of rows that are going to be in the observation for the range here. And then finally, we put it all together with the main function called moving average, or whatever we want to call it. Now, once again, we use the DAX formula called calculate, because we're going to run the concept of a measure over a scope. And in this case, we're going to calculate that concept of average sales here, which is the sum of sales dollars divided by how many months are in our observation, where the scope is going to be a range of dates using the date dimension from start month to end month across all dates. Now, some people get thrown by that all dates. Sometimes when they're learning DAX or they look at some basic examples, they stop here. And then they wonder why they either get an error message or they wind up getting the same number over again or simply not get the correct result. We are looking to run this over all the possible dates that are in the current scope. You keep in mind, in this case, the scope here is 12 months within 2007. So it is important to run this over the context of whatever dates happen to be in the slice of data. So this is actually a good example, even if you never write a 12-month average. There's some other techniques in here that you might possibly find helpful. Well, we also had in here the calculation of sales for last year. In other words, sales for the same time period a year ago. So in February of 2007, we might want to know what were the sales a year prior. And the same thing for any other month. Well, in DAX, there's actually a couple of different ways you can do that. Some people will use a function similarly to the function that you will see in MDX called parallel period. There's actually a function in DAX as well called same period last year. And that's actually the one that I'm using here. So what I'm doing is I'm running a calculation. So once again, we're going to aggregate something over a range of data. And in this case, we want to aggregate the sales dollars from Factbook sales for the same period last year based upon whatever the context is for the current date. So once again, when we use this calculate function and we want to run it over the range of dates in the current context, we use the all function with the dimension, in this case with dim dates. And so that winds up giving us whatever the sales happen to be for the same time period a year ago. So this is also one that somebody might want to put into their toolkit, put in their library of DAX functions. Just like when you learn a relatively complicated language like MDX or any other programming language for that matter, most developers are going to keep some examples at the ready, keep them close by in case they have to refer to them. And DAX is no exception. There are people out there who learn DAX by keeping some examples around that work and using that as a pattern for future examples. You certainly might not have this particular fact table in this particular dimension. It might be something different, but you still might be able to lift the technique. Now, another date function, I didn't actually show this last week, is one where we might want to calculate the sales year to date. Now, what I'm going to do, I'm going to move the chart out of the way because we actually had a table in the background. Well, we might want to calculate the sales year to date. So obviously in January the sales year to date would be the same as the sales for that month, but then it would cumulatively roll up for each month in the year. So become 8 or 9 million and then 12 or 13 million and so on, and continue to accumulate to the end of the year. Well, in this case, there is a function in DAX called dates YTD, where in this case we can calculate the sum of the sales dollars, not for the same period last year, but for the dates year to date. Now, I am actually rolling the dice here because right before we started, I had pulled in this calculation from another example, but had used a different dimension and hadn't tested it. So I'm actually going to roll the dice here and hope that I had done this one correctly. It was from a prior example that had a completely different context. But hopefully this will work here. So I will go to Factbook Sales, and I'm going to put in the sales for a year to date. So I will right-click on Factbook Sales and add a new measure. And I will call this Sales Year to Date. And copy and paste this in. And check the formula. And could not find Factbook Sales. And I believe in that case, you might have to put single quotes around it. And sometimes reading the warning here can be okay, so how about sales dollars? So I get 3 chances here. So let's try sales dollars plural. Okay, no errors in formula. Well, I'll click OK. And that's not formatted, in any way, but that is actually giving us the cumulative sales today for the year. So I'll come over here and I'll actually format that column so we can actually visually see it's the sum of the sales dollars, at least for that first month. So I'll right-click and format the cells and format that as currency. Like the entire thing. And stretch that guy out. And bring the grid lines back just long enough to stretch that out, and there we go. So obviously the test of a year-to-date is to make sure that the data for the first month is the same thing, and then that continues to accumulate. So that's up to 9 million and then 14 million and so on. And because we didn't have any sales in December, the data is the same as it was in November. So got it right in under 3 tries. So the sales year-to-date, now we had to put in this case, because I had not actually declared that, had to actually put the fact table inside of single quotes. So it's the sum of the sales dollars from fact book sales, and in this case we're calculating it over a scope of data where, based upon whatever the current context is for date, we're getting the dates year to date. So that's essentially determining a range of months from the first month up to whatever the current month happens to be. Now, there's actually also a sales quarter to date. It is essentially the same thing, except you call the function sales QTD instead of sales year to date. Now, if you're wondering, what would you do if you started at a particular time of the year instead of the beginning of the year? There is a parameter with dates year to date where you can actually specify a month and a day to use the starting point. I'm not going to do it here, but essentially the capability is something along the lines of a comma inside of dates year to date, and then in this case 0630, or excuse me, 0701 for the first day of July, if you actually want to start your year to date in something other than January the 1st. So you can, in dates year to date, actually provide an alternate starting point. Okay. I believe that's everything that I wanted to use for that book demo database. So just want to look through the examples here, because I'm going to switch over to the AdventureWorks demo. So at this point, we've looked at the sum of the return dollars. We looked at how we calculated a returns percent. We looked at calculating a rank. Looked at coming up with an average weighted goal from the threshold table. Looked at the author dollars, where we had to utilize the bridge table relationship. I said that we were going to look at percent of total a little bit later. We looked at the moving average, and we looked at sales last year and sales year to date. Well, I'm going to close Excel here. I'm finished with this example. I want to keep the amount of resources I have on this machine pretty good, so I'm going to close Excel. And I'm going to come back over to the tabular model in Visual Studio. And I'm going to go to the relationship area. So under the model, I'm going to go view the diagram. Well, a fair number of people have to implement this in line of business applications, where we have sales with three different dates representing 3 different business processes. We're capturing the order date, we're capturing the due date, and we're capturing the ship date. Now, you might use one of these as the primary date when you roll up data by month or year or quarter or whatever. So the order date might be the primary date, because you might use that as the basis to book liability for order dollars. But because due dates and ship dates are usually going to lag, at least a day or two, in all likelihood, you're going to want to look at sales dollars or maybe freight or some other measure from the fact table, not according to order date, but according to ship date or due date, depending on what the analytic requirement happens to be. Well, there are 3 primary key foreign key relationships that the model view picked up here. This is what's referred to conceptually as a role-playing dimension, because the date key and dim date is serving 3 different purposes or 3 different roles for the fact table. Well, the full-blown version of analysis services actually handles this very easily. The full-blown version of analysis services will generate 3 views off of the date dimension to make it very easy to look at any measure in this fact table by order date, due date, or ship date. So it basically creates 3 views off of this date dimension. It's three virtual or logical views. It's still only 1 dimension under the hood. Well, unfortunately, the tabular model and PowerPivot don't support that directly. Well, we can once again write some DAX code to address that shortcoming. Well, I'll come back to the data view. And in the fact reseller sales table, I've got 3 different calculations in here. For ship sales amount, order sales amount, and due sales amount. Now, they're all essentially doing the same thing. They're just pointing to 3 different relationships. Let me come back to Word here, since this is probably a little bit easier to see. I've got ship sales amount, where I'm once again calculating the sum of the raw sales amount measure over a scope of data. And in this instance, we can calculate something over a relationship. So I'm using the relationship between the date dimension, where the underlying key is the date key, and fact reseller sales, where the related foreign key is ship date key. So that will give a sales amount tied to the ship date view of things. And then again, we can repeat that same calculation for the order sales amount, simply using the relationship involving the order date key, and the same thing with the due date. So this is how we can get around the fact that the tabular model doesn't have direct support for role-playing dimensions. Now, I want to go test this in Excel. Well, remember, there is this really, really nice feature that they added in the tabular model, where if we want to go analyze this over in Excel, we can just simply click the Analyze in Excel button. That'll launch Excel and automatically create a connection string and let us start slicing and dicing this data right away. I can't tell you what a nice little feature this is. As somebody who's opened up Excel and had to build connection strings and point to the cube that you wanted, this is a great little feature to have. Well, we can test it with a role or with a perspective with another user. I'm testing it as me, and I don't have any perspectives built here, but we can switch them if we have them. And that launches Excel and allows us to interact with this tabular model even before we deploy it. Well, notice in fact reseller sales, I've got due sales amount, order sales amount, and ship sales amount. Now, over the scope of all the time, they're going to be the same. However, if I start breaking them out, for instance, I'll come down to the date dimension, and I'll take the English month name. These are columns that are in the full-blown version of AdventureWorks. And I'll drag that down to the row label area. And then I'll pick a year. Now, you might wonder, where's the slicer capability? If you don't see the slicer capability right here, you can, in the options menu, I had to go look for it for a second. In the options drop down, I can insert a slicer, and I'll base it on the calendar year. So even if you don't see it in the pivot table field list, you can still insert a slicer manually. And I'll do this just for 2007. Well, in several of the months, just because a lot of the AdventureWorks data happens to be very similar for the dates, in several of the months, they're going to be the same. However, there are one or two examples in here. I don't remember which year. I have to go find it. There are one or two examples where the numbers are different. And I just simply have to remember which month it was. Bear with me one sec. Yeah, here it is. In June of 2008, the order sales amount when the liability was booked is $3,415,479. The due amount and the ship amount are slightly different. They're actually slightly higher. So maybe we had orders that were placed throughout the month, but maybe a few had were ordered the prior month, but then came in that were due and were shipped in the month of June. So there's our demonstration that we can have a role-playing dimension and implement three different calculations using three different relationships. So nice feature to have. Now, so far I've been looking at DAX calculations inside of PowerPivot or inside of the tabular model. Well, what about Management Studio? Since T-SQL and MDX developers write code in Management Studio all the time. Well, the answer is yes. We can put DAX code into Management Studio. Now, what I'm going to do here, I had Management Studio open. I'm actually going to close it and reopen it because I want to demonstrate something here. So I'm going to close Management Studio and I'm going to reopen it. Okay, I believe, because I actually have 2008 and 2012 on my machine. I think that's one for 2012. My icons got moved around as soon as I started the presentation, so you know what happens when we start a presentation, the icons get moved around. All right, so, okay, here we go. So we're launching Management Studio 2012, and I'm going to connect to a deployed version of this AdventureWorks database. So I'm going to connect in Analysis Services, not to my standard multidimensional OLAP instance, but to the tabular model instance, and take Connect. And I'm going to create a new query. Now I need to point to the particular tabular model that I want. Well, I have one out here called ADW Test Tabular. So these are all the tabular projects that have been deployed. Well, let me come back here to my Word document. And what I want to do is I want to show a result set, because I might wind up putting this query into something for reporting services. I want to get a result set of sales from the reseller fact table within the with broken down by the day of week, and also get a number of the resellers that had sales on that particular day. So I'm going to paste in this code. I'm going to use one of these reverse engineering approaches. I'm going to execute this and then talk about it. So in the output here, I've got sales broken out for each year at AdventureWorks, for 05 through 08, and actually on down to 2010. And then I've got it broken down further by the English day name of the week. Now, keep in mind something. The granularity, in fact, reseller sales is actually by individual day and actually by individual invoice or individual sales order. Well, what I want to do is I want to aggregate by some other dimension or by some other attribute. Well, I'm going to wrap all this inside an evaluate statement. Evaluate is going to allow me to evaluate DAX code inside of an editor where seemingly what we would put in would be MDX. Notice how we actually had the metadata model over here for whatever measures we've created, any KPIs we created, and any dimensions that we want to slice data by. And so we can put an entire query inside of an evaluate function. And what I want to do is I want to summarize by the calendar year, but within the calendar year roll up based upon the attribute for the English day name of the week. And I want to sum the reseller sales. Now I can give it a name. I could actually call it sum of sales. So inside of double quotes I could actually put in sum of sales. And then I want to know the number of resellers who had sales on that day. So maybe on Tuesdays in 2005, we had 90 resellers. And on Thursdays in 2005, we had 69 resellers. So we see which day of the week is the biggest day. It appears to be Tuesday. Well, what we can do is we can call the function distinct count. It's actually a new function in DAX. There was no distinct count in DAX 1.0. You could do a count and then provide a distinct keyword. So you could get the same number, but you had to write at least two statements instead of one. Well, they created an actual distinct count. And I simply want to get a distinct count of the number of reseller keys within the scope of the week within the year. And then order this by the calendar year. So this is the kind of query that you can test out here in Management Studio and then implement this as a query for the basis of a report. Now, in some instances, you might not need to write the query because the built-in calculations that you might have put into the model might have been sufficient. But this is still a demonstration of how we can get a basic output. Well, I also mentioned there's another formula, another calculation that's in DAX, and this is one that MDX developers, especially more advanced MDX developers, have used, and it's called generate. We essentially use generate when we want to assemble a result set within a result set. It's sort of a cross, if I could use a T-SQL analogy. It's sort of a cross between a correlated subquery and the apply statement that you see with table valued functions. Essentially what I want to do is I want to display each of the years. And within each of the years, I want to get the top 3 resellers based upon the sum of the sales dollars. Well, if you could think of this, if this were a T-SQL statement, your outer list would be the dates, would be the years. And then your correlated subquery would essentially be each year being passed into another query to grab the top 3 resellers for that year, 1 year at a time. So logically, the generate statement works like a correlated subquery, where we want to take our outer list of years and then inside run a top count. In this case, get the top 3 resellers based upon the sum of sales. Now, notice how up above I've actually created a measure. Just in the same way in MDX, you can say with member such and such as, and run some aggregation, run some calculation. In DAX, it's a similar concept. You just write a little bit differently. You can say define measure and then give it a name and associate it with a dimension. So I'll paste this. Once my copy and paste works, I'll paste this over into a second query window. And I wind up getting each year, 05, 06, 07, and 08. I don't get 2010 because I'm running internal filter only where the sum of sales are greater than 0. So if we have a year without any data, we're not going to get any results. Well, in 05, the top 3 vendors were Tread Industries, Hardware Components, and Golf and Cycle Store. I could have also implemented the rank measure here as well. I could have associated the rank. I might, for next week when I show some different capabilities in reporting services, I might take some of these DAX formulas and add to them a little bit. I might put the rank in here as well. So we got the top 3 vendors for 05 and then the top 3 vendors for 06 and so on. Now, by the way, the outer set could have been a top 3 or a top 5 or a top something as well. So it could have been the top 3 products, and within the top 3 products, the top 3 resellers. In this case, it's just simply each of the years, and for each year, the top 3 vendors. And again, we're ordering by the year, and within the year, the sum of the sales. Interestingly, the order by here is a little bit more like a T-SQL order by than an MDX order by. If you've ever seen the order function in MDX, it's a little bit more involved, a little bit more complicated than an order by in T-SQL. So it almost looks more like a T-SQL order by. So once again, we can put these queries in Management Studio and test them out. Well, in the next few weeks, where we look at reporting services and Power View, again, I'll go back and take a look at these. And then finally, there was only one that I forgot to mention. I'll mention here quickly. I wanted to finish this on time here today. We might want to calculate a percent of total. In this case, the sum of the sales amount for any one vendor within a set of years. So we might be looking at resellers within years and want to calculate the percent of total. Well, what we can do in the numerator here is we can take the sum of sales amount. That gives us the sum of the sales amount for the current slice of data, and divide it by the sum of the sales amount for the related year, because again, we might be looking at resellers within year, and then across all of the resellers. So within the year or within the month or whatever date we're happen to be looking at, we might have 10 vendors and different dollar amounts for each one. Well, again, we can take the sales amount for that current slice and divide it by the sum of the sales amount calculated over a scope of data for whatever the related date dimension happens to be across all the resellers, whether we have 10 or 20 or however many we happen to have. So that's an approach that we can take to implement a percent of total. So I will put these up on my site. They'll be up later this afternoon. So again, coming back to the slide deck. My site here is www.kevinesgoff.net, and you can go up to the Microsoft webcast category that I actually have devoted in my blog and my website for this. And later this afternoon, I'll post that Word document up into the appropriate section. If you actually go up to my blog, you'll see that I've got a table with a different row for each week of this 13-week series. So I'll make sure that those samples are part of this week. So they'll be up later this afternoon. So, finished more or less right on time here, so thank you for attending. And we got two more weeks to go. Next week, we are going to take a look at the new reporting services integration capabilities with SharePoint. Just very quickly, what that's going to involve. If you've worked with reporting services in SharePoint before, you know that reporting services was never directly a service application of SharePoint. There was always a separate integration step that you had to go through, and while it was not all that difficult, there were some concerns that people had about the fact that it didn't run as an integrated service application. There were some issues with performance, And so Microsoft has actually added this as a service application within SharePoint. The result is that some of the integration points tend to perform a little bit better. The installation or the configuration is simpler. And if we utilize tools like performance point services, which is actually one of my favorite tools inside of SharePoint, the access to reporting services integration is maybe just a tiny bit easier. I'm actually going to show an example of how we could integrate reports in a performance point services dashboard next week. So the what's new with reporting services integration isn't really an hour's worth of conversation, not normally. So I'm actually going to use next week to show some things that we can do with reporting services reports once we push them up into SharePoint. Well, one of them is we can put them into a performance point services dashboard, which is sometimes an overlooked but actually a very cool feature. And then the final week we'll look at the new data visualization tool in reporting services called PowerView, and the types of rather interesting visualizations that we can create with it. So that's what we've got on tap for the next 2 weeks. So thank you all for coming. Have a good weekend, and hopefully see you here next week, same time, same station. So long, everybody. Have a good weekend, and hope to see you soon.